Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello future engineers, there is another video, sample problem video in calculus in order for you to master calculations and limits. And also if you want to anticipate the solution, you may do so by pausing the video. Evaluate the limits. So there are six exercises in this video. Then as I said, you may pause the video and solve these exercises by your own, then compare the answers presented here. If you made the perfect score, the, then the better. You're ready for other advanced topics in calculus. So for part A, limit of quantity y minus pi over 2 quantity square over 1 minus sine y as y approaches pi over 2. We are confronted here with indeterminate form because as y approaches pi over 2, the numerator approaches 0 square, so 0 approaching 0, and 1 minus sine of pi over 2 is 1 minus sine of pi over 2 is 1, so the denominator approaches 0 also. So to get rid of that 0 or indeterminate form, let's replace y minus pi over 2 by theta. And note that as y approaches pi over 2 minus pi over 2, theta approaches 0 as y approaches pi over 2. Then we replace y approaches pi over 2 as by theta approaching 0, and y here is theta plus pi over 2. This is theta square, and the y here is theta plus pi over 2. So that would now be limit as theta approaches 0 of quantity theta square all over 1 minus quantity theta sine of theta plus pi over 2. Expand sine of theta plus pi over 2, which is sine theta cosine pi over 2 plus cosine theta sine of pi over 2. So limit, that would now be equal to limit as theta approach 0 of theta square over 1 minus quantity sine theta cosine pi over 2 plus cosine theta sine of pi over 2. Cosine pi over 2 is 0, so this is 0. Sine pi over 2 is 1. So what remains here is cosine theta. Negative of cosine theta is 1 minus cosine theta in the denominator. So limit of theta square all over 1 as theta approach 0 over 1 minus cosine theta. And from trigonometric identity, we replace this by 2 sine square of theta over 2. So theta square over 2 sine square theta over 2. We introduce this, we divide this by theta over 2 quantity, then it becomes quantity square. So I also introduce 4 here because theta square is 4 in the denominator of the numerator. So limit as theta approaches 0 of 4 times theta over 2 quantity square, so that's still theta square, over 2 sine square of theta over 2. Actually, the limit of theta over 2 over sine theta over 2 quantity square is still 1. But let's have it in the form sine theta over 2 over theta over 2. You might not agree with theta over 2 quantity square over sine theta over 2 quantity square. The limit is 1. So this is the transformation. 4 over 2 is 2. Then we bring this down as the denominator of sine theta over 2 sine square theta over 2. So that becomes 2 over sine theta over 2 over theta over 2 quantity square. So limits of theta over 2 over sine of theta over 2 over theta over 2 is 1. 1 square is still 1. So 2 over 1 is 2. So the answer is 2. B. Limit as x approaches 1 of absolute value of x minus 1 over x minus 1. So as x approaches 1, the original, if we consider 1 from the left, like 0.99999, the value inside the absolute value bars would be negative. So absolute value of a negative value is positive, so that we transform that into negative of quantity x minus 1. Remember, the quantity inside is negative, so that's why negative of negative is positive. So that we can cancel x minus 1, and it would now be limit of negative 1 over negative 1 as x approaches 1 from the left. And the limit of negative 1 as x approaches 1 from the left is negative 1, because that is now a constant. While the limit of quantity x, absolute value of x minus 1 over x minus 1 as x approaches 1 from the right, is equal to, so 1 from the right, so this is the numerator. We can cancel this x minus 1 and x minus 1, so it becomes positive 1. The limit as x approaches 1 from the right is positive 1. Since the left hand limit as x approaches 1 from the left is negative 1, the right hand limit is as x approaches 1 from the right is positive 1. They are not equal, the left and the right hand limits. Therefore, we say the limit does not exist. So limit as x approaches 1 of absolute value of x minus 1 over x minus 1 does not exist, or there's no limit. Then we proceed to letter C. Limit as x approaches 2 from the right. We call this one-sided limits of square root of x minus 2 over x squared minus 4. We factor the denominator into x square root of quantity x minus 2 x plus 4 here. And we cancel square root of x minus 2. So that would be limit as x approaches 2 of 1 over square root of x plus 2. Now the denominator is no longer approaching 0, so it is safe to substitute 2. 2 plus 2 is 4, and square root of 4 is 2. So therefore the limit is 1/2. Letter D, limit of quantity 1 minus x squared to quantity cube raised to 1/3 over 1 minus x cubed quantity raised to 1/3. As x approaches 1, the denominator approaches 0, as well as the numerator, so we have indeterminate form. We then factor the numerator and the denominator. The common factor is 1 minus x. So limit of quantity 1 minus x squared, 1 minus x, 1 plus x, the factors raised to 1/3 over 1 minus x quantity 1 plus x squared. Remember that, then raised to 1/3. Remember that by difference of two cubes, cube root of 1 is 1, cube root minus cube root of x cubed is x, and the other factors, the terms of the other factors are square of 1, which is that, product, negative of the product, so 1 times negative x, then make it negative of negative x, so positive x, then square of negative x, so positive x squared raised to 1/3. So this is 1 minus x to the 1/3 over 1 minus x to the 1/3. We can cancel that. So it reduces to quantity 1 plus x to the 1/3 over quantity 1 plus x squared raised to 1/3 as x approaches 1. Since the numerator and the denominator, both numerator and denominator, do not approach 0 anymore, so it is now free of indeterminate form, so we substitute 1. So that would be 1 plus 1 to the 1/3 over 1 plus 1 plus 1 squared to the 1/3. And 1 plus 1 is 2, 2 to the 1/3. Denominator is 3, 3 to the 1/3. That would be 2 to the 1/3 over 3 to the 1/3, or simply quantity 2/3 to the 1/3. Letter E, it's the same. As x approaches 1 from the left, the numerator approaches 0, the denominator approaches 0 positively, both positively, because we have x from the left, so 0.999999. So we factor the numerator as limit as x approaches 1 from the left as square root of 1 minus x times quantity 1 plus x squared, just like in the upper part, over square root of 1 minus x times 1 plus x, quantity square root of quantity 1 minus x 1 plus x. So we can cancel square root of 1 minus x, leaving we have 1 square root of 1 plus x squared over square root of 1 plus x. So it is now safe to substitute x equals 1, x 1 from the left, 1 from the left is 1. So square root of 1 plus 1 plus 1 square over square root of 1 plus 1. So the numerator is square root of 3, the denominator is square root of 2. So that is square root of 3 over 2 times square root of 3 times square root of 2 over 2 to rationalize the denominator. So the final answer is square root of 6 over 2. And finally, part F, limit as x approaches 3 from the right of x minus 3 over square root of x squared minus 9. So we factor the denominator as square root of x minus 3 times x plus 3. So that would be limit of quantity x minus 3, square root of x minus 3, square root of x minus 3 over square root of x minus 3 times x plus 3. So the numerator originally is x minus 3. So we write that as square root of x minus 3 squared, or simply square root of x minus 3 square root of x minus 3. We can cancel square root of x minus 3. Then as x approaches 3 from the right, the numerator approaches 0. The denominator does not approach 0. So it is 3 plus 3, so square root of 6. While the numerator is approaching 0, square root of 0 is 0. 0 over square root of 6 is 0. So the limit is 0. So that's it for this video. I hope that you learn another useful information, useful technique, so that your brains will be prepared and enhanced and develop a little, as long as the brains are improved to think in a manner that is the same as that of a true engineer.